Hey there, it's Mr. Luneski here with Section 3 of Unit 5, still talking about triangles and proving two triangles congruent. Today we are looking at three more methods, or the last three methods I should say, known as angle side angle, angle angle side, and hypotenuse leg. So let's get started. In the last set of notes we learned about side 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 and side angle side as ways to prove triangles congruent. There are 5 ways total, so we're going to wrap up the other 3 methods here today. So the first method is called angle side angle, or ASA congruence. What this basically says is if two angles and the included side of one triangle are congruent to two angles in the included side of the second triangle, then the triangles are congruent. So included, remember, means between. So when I have two angles here and here, the included side is the side that's between those two angles. So looking here, we have angle, side, angle, and remember that they need to match up. So angle, side, angle. So in this one, I could say that B matches up with E, I could say A matches up with D, and C matches up with F. So I could say those two triangles are congruent. So oftentimes, a question that students usually ask is, how do I know which order to go in? Like, how did I know to go angle, side, angle? Why can't I go this way? Let me clear that. Why can't I go from here to here to here and call it angle, angle, side? Whenever you are looking at the marks that you have on the triangle, or maybe marks that you're making, there's one big major rule, and that is no skipping parts. So as you go around, you're not allowed to skip consecutive parts, meaning I can't go from here to here because when I start at this angle, I'm skipping this side and I'm skipping this angle, and I can't skip those two things together. Plus, I'm skipping a whole nother side. So I have to sort of meet up with an angle right away or meet up with a side right away. So from here to here, oh, I'm meeting up with that side, and then I'm meeting up with that angle. So that tells me to either go in this order, or technically I could go in that order as well and say angle, side, angle. The next one is angle, angle, side. So it's kind of the same idea, but except this time instead of having the included side, we're going to have a non-included side. So we have our angle, and a side. Now notice I skipped this side, but I pick up with an angle, so that's okay. And then I pick up with a side. I wouldn't want to go around this way because I'm skipping a side and I'm skipping an angle. You can't skip two things together like that. So this would be angle, angle, side. The next one, or the last one, is called hypotenuse leg. And what that states if the hypotenuse and a leg of a right triangle are congruent, then the hypotenuse and the leg of a second right triangle are congruent, then the two triangles are congruent. So, hypotenuse, remember, is the side that is across from the 90-degree angle. So that would be this side and this side. And then the leg could be either this or this. Either of these are referred to as legs. So I could maybe say this, and it has to be a right triangle. In order to use hypotenuse leg, it has to be a right triangle. So when you're looking at hypotenuse leg, you're essentially looking for 3 things. You're looking for the hypotenuse, the leg, and the right angle, making sure that the triangle has those 3 parts. So those are the 5 now methods of how to prove triangles congruent. So overall, when we start looking at proofs, there's sort of a list of things that we want to look for whenever we're proving two triangles congruent. So this is kind of like a little cheat sheet, little helper list. So as you're doing practices or studying, you may want to look at this part. So you may want to star this or something. So one of the things that you want to look for in these triangle problems are shared sides and shared angles. And how that relates to a proof, that's our reflexive property. So typically, we might see that looking something like this, or a shared angle might look like this, where they both share this angle here, or they share this side. That's our reflexive property. Something else you want to look for, are parallel lines. Anytime you have a problem with parallel lines, your mind should immediately switch over to alternate interiors or corresponding angles. So we looked at a few proofs with that in it last class. So if I had something like this, and I drew this, I could say that this and this are alternate interior angles, and that they're congruent. So just keep those things in mind. So when you see parallel lines, you really shouldn't be looking for a side congruency, you'd be looking for an angle congruency. Something else that we often look for are midpoints or bisectors. So if that's in your given that, oh, this is a midpoint or this is an angle bisector, how that translates is in our proof we would then use definition of midpoint or definition of bisector. And typically what that does is we set two segments congruent to each other, or we set two angles congruent to each other if it's an angle bisector. Something else that we often look for are vertical angles. Remember, vertical angles kind of look like the little bow tie problem. So I could say this is congruent to that. And when we translate that in a proof, that would be our vertical angle congruence theorem. So why can we say that the two angles are congruent? Because of vertical angles. So that's kind of just a quick little hint list on things that you want to look for in proofs and in some other problems as well, not just the proofs. So let's take a look, speaking of proofs, at a couple of proofs on the back. Don't forget about the 3-star method, that once we get our 3 stars, we can then prove the two triangles congruent. So in this problem, we are told that AB is parallel to CD and BC is parallel to AD. So that's going to be my first statement here. And we'll say BC. So that's our given. So think back to the hint list that when I have parallel lines, if you look here, I can't put a star next to this. It's not a congruency statement. So I need to now pull 3 stars. So when I see those parallel lines, I should immediately think of angle congruencies. So if I look here, if this is parallel to this, and here's my transversal, I can say that this angle is congruent to this. So remember, we don't just want to call that angle B and angle D, that we need to call it by its proper name. Angle ABD is congruent to angle CDB. So why is that? Because of alternate interior, not congruence, angle. Alternate interior angle theorem. Similarly, we can also say that this angle is congruent to this angle. So we can say angle CBD is congruent to angle ADB. For the same reason, the alternate interior angle theorem. So because the lines are parallel, alternate interior angles are congruent. And then finally, what else do we have? We have two triangles that are pushed up against each other, so we also have a reflexive property. So we can say something like BD is congruent to BD. So those are my 3 stars. Those are my 3 congruency statements, and that is reflexive property when I have a shared side. So now I want to look at, well, what do I have marked in my triangle? And if it helps you to kind of maybe ignore one of the triangles, so maybe say, ignore this for right now. What do you have marked here? You have an angle, a side, and an angle. And notice I didn't skip any parts. So now I can say triangle ABD is congruent to triangle CDB because of angle, side, angle. So one hint I want to remind you of is that our proof statement is always right there. So a lot of students are like, well, how did you know to write those letters? Because it's told right there. All right, let's take a look at another proof. So what are we given? We are given KL is congruent to JM. Hey, that's a congruency statement. That's a star given. So let's mark that. KL, that's this thing, is congruent to JM, that's this thing. What else are we given? We are given that NKL is congruent to NJM. Whoops. That's another given, and that's also another star. So angle NKL is here, Angle NJM is here. And so now we need to find that third star somewhere. So what we're noticing, we're trying to prove that these two triangles are congruent, the big ones. So what they're actually both sharing is they are both sharing this angle right here, angle N. So I can actually just call that angle N because there's no parts that are sort of cutting it off. So angle N is congruent to angle N. That's a reflexive property. Hey, I got my 3 stars. Let's prove these triangles congruent now. So triangle JNM is congruent to triangle KNL. So what did we use? Well, if we take a look here, I have a side, and if I go here, I'm skipping an angle, I'm skipping a side, I can't do that. I have a side, I have an angle, and I have an angle. So side, angle, angle, we write that as angle, angle, side. So realistically, we're kind of going this way with it. All right, one last proof to take a look at, and then I'm done. All right, so what are we given here? We're given AD perpendicular to BC, and we're given AB is congruent to AC. So let's start with that. That's a star because it's our congruency statement. So let's go ahead and mark that. Okay. So now our next given was AD is perpendicular to BC. That's also given. So now further what we can do is from here we can say that if these are perpendicular, we can say that this angle, angle angle BDA is a right angle. And we can say that angle CDA, I'm running out of room, sorry, I'll just say is right. Sorry about that, ran out of room. So now I know that both of these angles are right angles. Why do I know that? That's the definition of perpendicular. And so now if both of these things are right angles, I can say that those two angles are congruent. Why can I say that they're congruent? That's called the right angle congruency theorem. So basically, two right angles are going to be congruent to each other because they're both equal to 90 degrees. Alright, so that's a star as well because we have a congruency statement there. So then what else can we say? Well, we have two triangles pushed up against each other. We can say that AD is congruent to AD. That's a reflexive property. That's our third stars. We just figured out Blue's Clues. And now we can prove these two triangles are congruent. So now when I look at what I have here, I have an angle, I have a side, and I have a side. But uh-oh, that spells the bad word, and that one actually doesn't exist. And I'm going to talk more about that in class as to why we can't use that. But we have a right triangle, so when we have right triangles, that's when we use hypotenuse leg. So angle side side does not exist. We'll talk more about that later. Thank you for watching.